Okay, this is going to be the first lesson in our 8th grade algebra book. It's the purple book. Hopefully you've already watched the video on how to access the materials in that book. So the first thing I want to do is kind of rearrange. These are, this note packet is one that I gave you before we left school. And we're going to call this 11.3. It's the third lesson in chapter 11 of the purple book, Simplifying the Rational Expressions. And just to define it, so if you need to print another copy, I have attached a scan of all of the notes that we will be taking in this unit. We may be able to get to lesson 11.7. I don't believe there's examples here, so there'll be a different set of examples or a handout with examples for you to add at a later date. But let's get started. This will be something that you definitely want to have some experience with before you get to high school. So to define a rational expression, we want to call this an expression that can be written in this form. So the form is going to be polynomial over polynomial. Okay, so the numerator and the denominator. And if you remember, our polynomials, and a lot of the ones that we've worked with, have been of the quadratic, meaning that the leading coefficient and or the leading term has a degree of 2. So with a term of 2, but there's all kinds. I mean, we could have monomial over monomial, and it would be considered a polynomial. So here, let me give you a few examples just to kind of let you know. So the main thing and the most important thing is when we talk about these excluded values. And the reason that is important is because one of the number one rules in mathematics is that you cannot divide by 0. So if you're looking at these variables in the denominator, we have to make sure that at no point could we simplify and have, that's a 2, have the denominator equal to 0, okay? So, you know, big important here. The denominator cannot equal 0, right? And that's mainly because we cannot divide by 0. So if we wanted to maybe, you know, look at the first one we could say, well, x cannot be equal to 0, right? That's an excluded value. For the second one, we could say that x could not be equal to 3 because 3 minus 3. And then what we're going to be doing with our trinomials is we will be factoring them. So if we're looking for factors of 25 that would sum to a negative 10, I believe it would be 5 and 5, and it would be negative 5 and negative 5, right? So we would have, in factored form, x minus 5 and x minus 5. So the excluded value would simply be x could not be equal to 5. So when you have the factored form, remember we want to use that product property of 0, that you just always set the denominator equal to 0 and solve for x, and those would be the values that could not be included. So it's going to be asking you for excluded values, so we want to keep in mind. So in example 1, we want to look about how we could simplify this. We have an expression, you know, a polynomial on top is a binomial and a binomial on the bottom. Look for things that can be factored. So in the numerator, we can factor the numerator here, and we would say, okay, 6x and 12 both have a common factor of 6, So we could factor out of 6, we'd be left with x plus 2. And then the denominator is x plus 2. So now our common factor and what we can cancel is this binomial x plus 2. So we can cancel it out. I always like to make sound effects, sorry. And we could say that the simplified form is 6. And what values would be excluded? So we always want to go back to the original problem to look for the excluded values. And the only thing that would make this equal to 0 is if x were equal to -2, so therefore x cannot be equal to -2, okay? All right, so if you want to pause the video, make sure you have everything written down. I'm going to be erasing this so that I can scroll down and get to the next part. Okay, because we're going to be doing several examples today. Oops. Okay, we'll start there. All right, so here's several that you can try to make sure that we're understanding the concept. So when I look at the numerator and the denominator, I'm looking for things that I can cancel, and I know that 15 and 25 both have a common factor of 5, and then there's b as a variable in the numerator and denominator. So I could factor out a 5b from the numerator, and I'd be left with 3. I can factor out a 5b from the denominator, and I'm left with 5b. So those are what cancel. So what I get is 3 over 5b as my simplified form, and I go back to the original, and the only thing excluded would be 0. Okay, moving on to the next one. The 12, the 3, and the 6 all have a common factor of 3. So since 6 does not have a factor of c, we cannot have a c, that we're going to cancel. So we want to cancel out a 3 or factor out a 3 from the numerator, and we're left with 4c squared. We can factor out a 3 from the denominator, and we're left with c plus 2. The 3's cancel. All right, and we are left with, in simplified form, 4c squared over c plus 2, meaning that there's no other common factors. Here, the excluded values would be, now in this case, you want to make 3c plus 6 equal to 0, and so if you subtract 6 and then divide by 3, you would have that c could not be equal to a -2. That's the excluded value here. Okay, and you're going to be asked online to be putting in the excluded values. Okay, moving on to the next one. 4m minus 2 over 2m minus 1. So I know that I could cancel out or simplify a factor of 2 in the numerator. So if I factor out a 2, it's like taking 4m divided by 2, and I'll get 2m. And then I have the -2 divided by 2, which is -1. And that's all over the 2m minus 1. Oops. You can make any sound effect. You can make a lightsaber, you can make, anything you want. It kind of makes it fun. All right, now we know that we have a simplified version of this that is equal to 2, okay? We have to make sure that we understand what the excluded value is. So again, I want to take the 2m minus 1 equal to 0, and then I would get m cannot be equal to 1/2. That would be what would make a denominator of 0, and we cannot divide by 0. All right, moving on to the next one. We will be factoring trinomials again. So if you need to brush up on that, it was chapter 7. And when the leading coefficient is 1, it makes it a little bit easier because we're looking for the factors of in the denominator here, positive 6 that will sum to a negative 7. And if I look at the numerator, I see that I have a factor of 2 that I can cancel out. So 2, and then I'll have x minus 6. And then I'm looking for two factors here, two binomial factors, and I'm going to have x, and then I want, so they have to multiply to equal a positive 6, but when I add them together, it's a negative 7. So remember, two negatives multiplied together make a positive. So I believe it's going to be negative 1 and negative 6, because when I add negative 1 and negative 6, I get negative 7. So minus 1 and minus 6. Then we have a common factor of x minus 6. Ching, ching. See, you can change the sound effects. All right, so we are left with a simplified version that is 2 over the x minus 1. That's our simplified rational expression here. And we're going to have two values of x that are going to be excluded, and that comes from the factored form right here. So if you remember, when we were solving the equations, we were setting them equal to 0. So we're looking at the zero product property where either x minus 1 would be equal to 0 or x minus 6 would be equal to 0, and then that whole denominator would be equal to 0, and that needs to be excluded. So the values that are excluded are going to be x cannot equal 1 and x cannot equal 6. Those are the two excluded values that would make that denominator equal to 0. Okay? This is another time to pause the video and make sure you have everything written down, because I'm about to clear the screen. And we'll continue. So we'll try a few more. Okay, so in this first one, try it, 3x plus 12. I know that they both have a factor of 3, and then I have a trinomial in the denominator, and I'm going to be looking for factors of negative 20 that will sum to a negative 1. So since it's a negative 20, one will be positive, one will be negative. 5 and 4 have a difference of 1, so I would need the 5 to be negative. So let's go ahead and simplify the numerator, as we'll factor out the 3, and we're left with the x plus 4. When I factor the trinomial, I'll get x minus 5 times x plus 4, and this will be a good place to start looking for what those excluded values are. So you almost need those trinomials factored before you can find what would be equal to 0, right? And we know that we cannot have x equal to 5 or negative 4 in this case. But we see a common factor of x plus 4 that can be canceled. Choo, choo. All right. And then we have a simplified version here where we have 3 over the x minus 5. And this is why it's important that you look at the original problem to get the excluded values, or you would miss the whole idea that a negative 4 would be excluded. So we cannot have the x equal to 5. We cannot have the x equal to negative 4. And that would be like if you substituted these values into the original problem, would give you a denominator of 0, and that is undefined mathematically. So we have to make sure that we're understanding what those excluded values mean. Okay, looking at the next one. Hopefully you can tell by the numerator that they would have a common factor of 8. And now we're going to be doing a factoring a trinomial without a leading coefficient of 1. So that makes for a few more trial and error. And we found the factor fish really helpful in that. So you put, you have your A, B, and C. So let's put A, which is 2 here. We'll put C, which is also 2 here. We'll draw a little factor fish thing. And then we can put B here, which is a positive 5. Now we're looking for two factors of positive 2, so I'll just easily put 1 and 2. And again, positive 2, so 1 and 2. Now to test it out, I would multiply across. 1 times 1 is 1, 2 times 2 is 4. Now I would add these together and they equal 5. So this will allow me to look at the cross pattern here. And the variable a goes with the first term. So it would be, so I'll have my numerator becomes a plus 2. And then my denominator, I have an a plus 2. And then I also have a 2a plus 1. And if you ever want to test out whether factoring is working for you, then make sure that you FOIL it, first, outer, inner, last, and make sure that you can come up with the original trinomial. That's always a good test to check your work. Okay, so my common factor here then becomes a plus 2. But this is the point when I want to find excluded values, because I either have a plus 2 equal to 0 or 2a plus 1 equal to 0. So here's my factor, the common factor, and I will, all right. So I have 8 over the 2a plus 1, okay, and excluded. I cannot have a equal to a negative 2. All right, that's the first one. And if I subtract 1 and then divide by 2, I also cannot have a equal to a negative 1/2. So make sure, I know that on Big Ideas it will be asking you for the excluded values. So if you want to pause the video and give the next one a try, just to kind of test to see how you're doing and understanding and comprehending, please do that. I'm going to continue because you have the ability to pause. So I need to factor the trinomial in the numerator. And so if I look at the numerator, I have factors of negative 6 that sum to a negative 1, so that probably is negative 3 and positive 2. So I have c plus 2 times c minus 3. So you always want to check that. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So that should work, or you could FOIL it to double check. Looking at the denominator, again, coefficient of 1 leading, so I can do a positive 6 with the negative 5. Since the middle term is negative, I have a feeling that both, oops, I know what happened here. This actually was, when I wrote these notes, happened very quickly on the morning of our last face-to-face meeting. So I did make a mistake. So make sure that you have written down c squared plus 5c plus 6. So this is going to mess you up completely with, I wish I could rewind now and edit out when I said pause the video and try it, because I didn't let you know about that. So if you want to be mad at me, you can yell at me on email. I apologize. So yeah, that probably, I'm thinking it might have been unfactorable. Maybe not. I don't know. Yeah, to have a positive 6 but a negative 5, I would have come that way. I apologize. I do apologize. I am so sorry. Okay, here we go. So let's try it now with a positive 6 and a positive 5, which is going to make them both positive, which would be c plus 2 and c plus 3. Oh, my goodness, that looks like a c, so I thought it was the parenthesis. All right, good. So now we can see that we have the common factor of a c plus 2. Oops. All right, and so our simplified rational expression is c minus 3 over c plus 3. Again, we have to look at this right here to decide which would make the denominator 0, so that we know we can exclude c cannot be equal to negative 2, and c cannot be equal to a negative 3. All right. This is a 3. It's kind of going over the arrow there, but okay. Again, I apologize for that. All right, I am about to erase everything that we have in front of us. Make sure that you did correct this problem so that the denominator has a c squared plus 5c plus 6 in order to do this problem correctly. And now we're going to turn to the back page. We're going to look at a few problems with common, patterns of difference of two squares, but we'll also have some negatives. We're going to rearrange some of the terms and factor out some negatives. So the first thing that I would want to do in the first problem, I can see that I'm going to factor out a 5 in the numerator. So I can do that. And so I can factor out my 5. And I'll have x minus 3. But in my denominator, I want to rearrange the terms. So if I have a negative x squared plus 9, not plus 9, silly Miss Kleinman. Oops, that didn't change to an eraser. Then it went crazy erasing. All right. Oh, it is plus 9. What was I thinking? Okay, it was plus 9 because it's a positive 9 right there. Okay. Boy, can you tell how long it's been since I've recorded some videos. It's been a while. All right. So, looking at the denominator, I guess you can look at it as a difference of two squares, but I like to have the variable term first. And I noticed that with this plus sign, it's not a difference of two squares. We don't like a leading negative coefficient, so we can factor out a negative 1. So I keep my numerator as x minus 3. If I factor out a negative 1, I would get x squared minus 9. And here is the difference of two squares pattern that we were talking about. So I know that at the difference of two squares, I would have, if I come down here, 5 over x minus 3. I have this factor of negative 1, and I have x minus 3 times x plus 3. It's kind of like those conjugates from our quadratics unit. Okay, so now I want to, this is the point where I want to find what are my excluded values, right? I do not want x equal to 3, and I do not want x equal to negative 3, okay? The common factor is right here. And this negative 1 will make the whole thing negative. So 5 over x plus 3. And again, remember, x cannot be equal to 3, and x cannot be equal to negative 3. We cannot have a denominator equal to 0. All right, under try it, I double-checked. There are no mistakes as they were copied down. But if I rearrange the terms in the denominator for the first one, I'll have x minus 4 over a negative x plus 4. So then I can factor out the negative 1. So x minus 4 and negative 1 times x minus 4. So I get the common term, expression, x minus 4 as my common factor. So this is equal to negative 1. And what are my excluded terms? I cannot have x, looking at the original problem, x cannot be equal to 4 because that would give a denominator of 0. So x cannot equal 4. So that's basically going to be excluded from your domain. Okay, so when I look at the middle one, I want to rearrange the terms, and I have negative m plus 8. The reason that you always want to put it in standard form, which is what I've been doing by rearranging the terms, is because it'll help you to see. Like if I look at the first one that I just did under try it, x minus 4 and 4 minus x, they both have x's, they both have 4's, but I couldn't just cancel them out as is, right? I had to factor out that negative 1 first. So I'd have to be in standard form in order to be able to find the common terms and expressions to cancel. That's how I would put it. And so the denominator is already in a difference of two squares. So we know that we could have m plus 8 times m minus 8. Now, we cannot cancel anything at this point because the leading term in the numerator is a negative m, and both of the expressions in the denominator are positive m. So if I factor out a negative 1 from the numerator, I would be left with m minus 8. Now I have a common expression. Okay, and it's at this point, with the denominator factored, that I can find my excluded values. So my m minus 8. So that would give me a negative 1 over m plus 8 as the answer, or the simplified form. And I know that m cannot be equal to negative 8, and m cannot be equal to a positive 8, or I would have an undefined fraction. All right, on the last one, I know there were quite a lot of examples on this one. We want to rearrange and put in standard form the numerator. So minus 4r plus 8. Okay, let's factor the denominator. I know that I will have values, right, that will multiply, so the factors of negative 8 that would sum to a positive 2. So if I have a negative 8, one positive, one negative, since my middle term is positive, the higher absolute value is positive. So let's try r plus 4 and r minus 2, and then double check it either through FOIL or just double checking the multiplication. 4 times negative 2 is negative 8, and 4 minus 2 is positive 2, and that should be enough. So in the numerator, I can factor out the greatest common factor would be a negative 4, okay, and then I'll be left with r, and 8 divided by negative 4 is minus 2. Make sure to calculate or figure out your excluded values. Find your common factor. So we have negative 4 over r plus 4 as our simplified answer. And we know that r cannot be equal to negative 4, and r cannot be equal to a positive 2. Okay, so this concludes the first lesson in our new unit. There will be some problems assigned for tomorrow for you to practice on big ideas if you want to start giving them a try today, or if you want to, get in contact with me, email me with some questions that you might have from some of the examples that we did today. All right, thank you.